In this episode of the Grinding Chronicles, we're going to talk about crankshaft grinding. This is a complex, multi-step process that can include both cylindrical and surface grinding operations. What makes this type of grinding unique is that the grind itself plays a critical role in crankshaft performance.
Welcome to the Grinding Chronicles, presented by CDT Engineering Consultant, who we call the Abrasive Avenger, also known as John VanSant.
Hi, I'm John VanSant, Engineering Consultant at CDT. In this episode, we're going to look at the parts of a crankshaft and talk about the various processes involved in crankshaft grinding. A crankshaft is made up of several features that require grinding. At one end, you have the post, where a pulley will eventually be attached. At the other end, you have the flange, where a flywheel will ultimately be mounted. Then you have two types of journals. The main bearing journals, also called mains, run through the center line of the crankshaft. This is what the crankshaft sits on in the engine block. One of the main bearing journals will have thrust walls that limit axial motion in the engine. Rod journals, sometimes called rods or crankpin journals, are positioned at an equal distance around the shaft. These are the parts that drive the pistons up and down in the cylinder. For every rod journal, you'll also have counterweights that counter the swing of the rods and keep the cylindrical motion balanced. Crankshafts can go through several grinding processes depending on whether you grind the rods and the mains together or separately. One method for grinding rods and mains is full-form plunge grinding. Your grinding wheel will have the contour of what the finished journal will look like. As the name suggests, it plunges in to make the form. As the crankshaft rotates, the wheel head feeds straight into the journal to its final depth and pulls off. Another method for grinding rods and mains is vector grinding. One important thing to understand is that rod journals are generally wider than your main journals. To avoid using two different wheel widths to grind, you can use a narrow wheel to grind both the rods and the mains. In vector grinding, the grinding wheel runs down one side of the journal, and then they'll traverse and trace the contour of the radius and side grind on the way out. Most often, the thrust wall is plunge ground, but there are some instances when you might traverse and then side grind in the wall to get the width. As far as the finished part, the end result is the same. It's just how the machine tool does it. Whereas the vector grinding is moving at angles and interpolating that radius, almost like a lathe, the side grind is coming straight into it with the side of the wheel. Finally, there's post grinding and flange grinding. These are plunge ground, with the wheel head oriented at 30-degree angle to the shaft. During the process, the wheel head will feed in from the end and grind the OD and the face of the post or flange at the same time. At CDT, we have extensive knowledge and experience in crankshaft grinding. If you have questions about your current crankshaft grinding wheels, or if you want to optimize your grinding process, contact our engineering team at TheGrindingChronicles at cdtusa.net.
Thanks for watching. If you enjoyed this video, hit that like, follow, and subscribe button, and get ready to learn something new in another episode from Continental Diamond Tool.